Hello, this is a review for the midterm 1. We're going to be starting off with some problems here. So the first problem for sequences would be if you were given a sequence like 1, negative 2 thirds, 4 ninths, and negative 8 over 27. If you were given this sequence and asked to find a general formula, then you would first have to find what is the first term. So what is the a value? The a value is the 1. So you now know a is 1. And what is the r value? Let's see. So you can see this is a geometric sequence. So multiplying 1 by negative 2 over 3 would get you negative 2 over 3, and multiplying negative 2 over 3 by negative 2 over 3 would get you 4 over ninths. So the ratio must be negative 2 over 3. And with a and r, we have our general formula. That would be 1 times negative 2 over 3 to the power of n minus 1. Remember, it should follow the general formula, ar to the power of n minus 1. And you can even double check this. When n is 1, so the first term, you would have 1 times negative 2 over 3 to the power of 0, which is just 1. So 1 times 1 is just 1, so the first term would be 1. And, when n is equal to 2 for the second term, and so on and so forth. Okay, and that would be the first problem completed. If you were given the general formula, let's say an is n over 2n plus 1, and asked to find out if this is convergent or divergent. First of all, this is a sequence, so you can find this by finding the limit of this sequence. So the limit as n goes to infinity of n over 2n plus 1. So to solve this, you can multiply both the numerator and the denominator by 1 over n. So you'd multiply the numerator by 1 over n and then the denominator by 1 over n. And you can do this because 1 over n divided by 1 over n is 1. So then that would leave you with 1 over, that is 1 over 2 plus 1 over n. And as n goes to infinity, 1 over n becomes 0. So that leaves you with 1 over 2 plus 0, which is just 1/2. So you know the limit of n over 2n plus 1 is 1/2, and thus this sequence does converge to 1/2. All right, and remember, for a series, so not a sequence, a series, if the limit does not converge to 0, then the series itself would not be convergent. So this is just a sequence. So for a sequence, if the limit is a finite number, then it is convergent. Okay, now let's look at a slightly harder example. If an were to be 3 plus 5n squared over n plus n squared. Okay, and you were asked to find whether this sequence would be convergent or divergent. You would find the limit as n goes to infinity of 3 plus, just, there we go. And then you would do the same as what we did in our previous equation. You would multiply both the numerator and the denominator by 1 over n squared and see what that would leave us with. That would leave us with, let's see, as the limit goes to infinity, that would leave us with 3 over n squared plus 5 all over 1 over n plus 1. And so, as you can see, as n goes to infinity, 3 over n squared is 0, and 1 over n would also be 0, so you end up with 5. So this converges to 5. So the sequence would end up as 5. Now, moving on to series, let's say you were given a problem like this. The series of infinity of from n of 1 all the way to infinity of, let's see, of negative 3 to the power of n minus 1 over 4 to the power of n. So let's say you were asked to find the sum of this series. So the first thing you could do, you would have to, I suppose, simplify the numerator, because this is pretty ugly. We don't want that. So we could simplify this as, let's see, simplify this as negative 3 to the power of n times negative 3 to the power of negative 1 all over 4n. So remember, this is a series. Okay, so you have that. Now, negative 3 to the power of negative 1. Well, I mean, that is just negative 1 over 3. Now you have negative 1 over 3 times the power of, let's see, negative 3 to the power of n over 4n, which, again, this is equal to just negative 1 over 3 times negative 3 over 4 all to the power of n. And this should look familiar to you because this is following the geometric series form for AR power of n minus 1, but we won't have a minus 1 because this n starts at 1. So we can use the geometric sum formula, which was a 1 minus over 1 minus r. A is the first term, so the first term that we find would be when n is equal to 1. So when n is equal to 1, this value would be equal to negative 3 over 4 times negative 1 over 3. That gives us 1/4. So we would end up with 1/4 is A, and R is just negative 3 over 4. So the entire equation would be 1/4 over 1 minus negative 3/4, so that's the same as plus 3/4. 3/4. That is 1/4 divided by 7/4. So divided by 7/4 is the same as multiplied by 4/7. And that gives you 1/7. So the sum of this series is 1/7. Okay. And of course it is convergent. Let's see. Let's take a look at another one. We have the series of, let's see, we have the telescoping series of infinity, n is 2. We have the series 2 over n squared minus 1. And you'll see here that if you write this out, you will get n 2 over n plus 1 times n minus 1. And so this is actually a partial fraction. You would use partial fraction decomposition here. So let's see. So you have 2n 2 over n plus 1 over n minus 1. And you would decompose this like this: a over n plus 1 plus b over n minus 1. You would multiply both sides of the equation by n plus 1 times n minus 1, and that would leave you with 2 times a n minus 1 plus b n plus 1. So now, with that, when n is equal to 1, you'll have n minus 1 would be equal to 0, so that's 0 times a. A would be canceled out. You'd have and n plus 1 would be equal to 2. So you'd have 2b is equal to 2. All right, for n is equal to 1. Okay, and when n is equal, so b is equal to 1 now. When n is equal to -1, n plus 1 would be equal to 0, so that's 0b. And you'd have n minus 1 would be equal to -2, so that's -2a. You have 2 is equal to -2a. A is equal to -1. So you have the a value and the b value. So all of that leaves you, with 1 over n minus 1 minus 1 over n plus 1. So this is your new partial fraction that you got from the original equation. So this is a telescoping series. So remember, the original equation was n to 2 of 2 n squared minus 1. So as a telescoping series, you would write this out. So you would end up with, let's say, 1 over 1 when n is equal to 2, minus 1 over 3 plus 1 half minus 1 over 4 plus 1/3 minus 1 over 5. And you would see a pattern there up until, let's see, pattern there, let's see, up until 1 of n minus 3 minus 1 over n minus 1 plus 1 over n minus 2 minus 1 over n plus the final term, which is 1 over n minus 1 minus 1 over n plus 1. All right, so you will see that the middle parts should cancel out. Leaving you with 1 plus 1/2 minus 1 over n minus 1 over n plus 1. Now, when n goes to infinity, 1 over n is just 0, and 1 over n plus 1 is also just 0, so you are left with 3 over 2. So the series of 2 over n squared minus 1 from 2 to infinity is 3 over 2. Alright, so now we're going to be looking at, let's see, we're going to be looking at the integral test. So let's say we had something like a series of n is equal to 1 to infinity of 1 over 2n plus 1 cubed. This would be cubed, right? And so we want to use the integral test to test for convergence or divergence. So we would turn this into an improper integral from n to infinity of 1 over 2n plus 1 cubed. So we just want to solve that integral, right? And solving that integral, we can use something like u substitution. So you'd have like 1 over u cubed, u being u being 2x plus 1, and this should be x. Yeah, this should be x. That's dx. Right? Du would be 2 dx, and thus dx would be equal to du over 2. So integrating this, we end up with, let's see, this is 1/2 integration 1 over u cubed du, which is equal to, remember the integration rules, you have 1 over, let's see, this is negative 2u cubed, squared, should be negative 2u squared times 1/2. So all in all, our and u is 2x plus 1, don't forget that. All in all, our integral would end up being solved as negative 4 2x plus 1 squared from infinity to n, which when x is infinity, the denominator is extremely large, so that's just close to 0. 0 minus, and this is, and when n is 1, so n is 1 here, when x is 1, 2x would be 0 minus 1 over negative 4 times 9, which is positive 1 over 36. So now that is the sum. It is 1 over 36, and you know this series is convergent. All right, let's take a look at another problem. This one is about estimating sums. So let's say you had a series like n is equal to 1 to infinity 1 over n squared, right? And so you want to find how many terms it takes for an estimate within 0.0001. All right, so the first step would be turning this into an improper integral. Of 1 over x squared dx, and finding this integral is not so difficult. You'll end up with negative 1 over x from n to infinity. Again, with infinity, negative 1 over infinity is just 0. So that's 0 minus negative 1 over n, which gives you 1 over n. So now that you have that, remember that we have the estimate, r of n, will be less than this equation, 1 over n. R of n is 0.001. All right, less than 1 over n. You can raise both sides to the power of negative 1, and 1 divided by 0.001 is 1,000, and 1 divided by 1 over n is just n. So n is greater than 1,000, n is 1,001. So this is the smallest term that will give you an estimate of less than 0.001 for this series. Now let's look at comparison tests and limit comparison tests. Let's say you had a question like this. Of 4 plus 3 to the power of n over 2 to the power of n. So notice that a really good, I suppose another series to compare it to would be something like 3 to the power of n over 2 to the power of n, because the series of 3 to the power of n over 2 to the power of n is a geometric series, and that has a ratio of 3 over 2, which is greater than 1, so you know this is to be divergent. And for the original series, the numerator is slightly bigger than the numerator of 3n over 2n, 3 to the power of n over 2 to the power of n. So you know that this series is bigger. So you can use the direct comparison test to say that this series is also divergent. Because this series is also divergent, and any other series that are bigger will also be divergent. Now let's look at another one. Let's say you had one over radical n squared plus 1, and you wanted to find whether this was divergent or convergent. A good series to compare this to would be, let's see, perhaps the series of 1 over radical n squared, which is just equals to 1 over n. So you know this series is divergent. However, to use the direct comparison test, the original sequence would have to be larger, and because its denominator is slightly larger than the denominator in 1 over radical n squared, it is actually smaller. So we cannot use the direct comparison test. We will use the limit comparison test. So now let's say we divide we find the limit as n goes to infinity of 1 over n squared, the radical of n squared plus 1, divided by 1 over radical n squared. This would actually end up with, this would give you radical n squared over radical n squared plus 1, which is equal to just n over n squared plus 1, but you're not done here. As n goes to infinity, both the numerator and the denominator goes to infinity, so perhaps you should simplify it by multiplying both the numerator, and the denominator by 1 over n. So multiplying n by 1 over n gives you 1, and multiplying the radical of n squared plus 1 by 1 over n may seem tricky, but 1 over n is equals to the radical of 1 over n squared. So really you would have the radical of 1 over n squared times the radical of n squared plus 1. And what does that give you? That gives you 1 over, so n squared over n squared would be just 1 plus 1 over n squared. Sorry for the conversation in the background. So when as n goes to infinity, this is equals to 0, giving you a grand total of 1. So remember, we're using the limit comparison test here. And for the limit comparison test, because the quotient of these two limits is positive and non-finite, we know they are either both convergent or both divergent. Because we know the series of 1 over radical n squared is divergent, the original series must also be divergent. So divergent because of the limit comparison test. All right, so that is just an example of questions from sections 1 to 4. Hope you guys have a nice day and good luck on your exam.